Okay, for this next lesson, we're going to be learning about using trigonometry to find the unknown angle in a right angle triangle. Now, obviously, in a right angle triangle, you already know what one angle is. It's a right angle. But if the other two, in order to work out what one of the other two angles is, you just need to know the length of two sides. And really important that we understand from a point of view of using our calculator what the different sine, cos, and tan functions do, and when we need to press shift beforehand and when we don't. So in these ones, when we're trying to find an angle, we need to use the shift button. All right, so when you press sine, cos, or tan, normally, that just finds a distance. But when we press shift first, so in this case shift cos, you get that cos to the -1, that's going to find us an angle. So for this first example, for instance, if cos theta equals 0.63, then theta must equal cos to the -1 of 0.63. Okay, so we just plug that into our calculator. So 0.63, close our brackets, and there we go. So it's also asked for us to give the answers to the nearest minute. So remember, we press the degrees, minutes, seconds button, and that's going to give us an answer. Now, in this particular case, it's 50 degrees, 56 minutes, and 59 seconds. 59 seconds, of course, is going to round up, so we'll end up with 50 degrees, 57 minutes. And that's how we do the first one. Now, in this second example, the process is still the same. If sine theta equals 2/3, then theta must be sine to the -1 of 2/3. So we put that in a bracket. So remember, every time we need to find an angle, we press shift before the trig ratio. That'll get that to the -1. When you see that there, that means you're trying to find an angle, not a distance. 2/3, close our brackets, and we end up with 41 degrees, 0.81, but of course in degrees, minutes, seconds. So that's going to be 41 degrees, 48 minutes and 37 seconds. 37 is more than 30, so it rounds up. So it'll be 41 degrees, 49 minutes. Okay, and the final example here, theta, if tan theta equals 4.6, then theta equals tan to the -1 of 4.6. We'll run that into our calculator. So tan to the -1 of 4.6. And that's going to give us an answer in decimals. We change it to minutes, degrees. So we've got 77 degrees, 44 minutes and 6 seconds. 6 seconds does not round up. It stays where it is. So 77 degrees, 44 minutes. Okay. Now the process as we go on is just the same as it is for when we find the side. We still need to figure out which trig ratio we're going to use and then calculate it up. So in this particular example, the side opposite the right angle is used, so that's the hypotenuse. This side here is adjacent to the angle, it's touching the angle. So if we think of SOHCAHTOA, what is the ratio we'll need? It's going to be cos. So still write out that basic formula. Cos theta equals the adjacent over the hypotenuse. If we just write it out in this form every time, you just fill in the blanks with what you know and leave everything you don't know. So I don't know what the angle is, so I'm going to leave that as cos theta, but I know the adjacent is 3.2, and I know the hypotenuse is 5.5. So therefore theta must equal cos to the -1 of 3.2 over 5.5. So I'll run that through my calculator. Shift cos 3.2 over 5.5. And we close our brackets, and that gets our answer. Now it's asked to the nearest degree, so 54.4 degrees is going to stay where it is. It's not going to round up, so it'll just be 54 degrees. Okay, moving on to the next question. So in degrees, correct to 1 decimal place. So here's our reference angle. We have the side that's opposite our angle, not touching our angle, and we also have the side that's opposite the right angle, so that's the hypotenuse. So which ratio do we use when we're involving the opposite and the hypotenuse? Well, that's going to be sine. So sine theta equals the opposite over the hypotenuse. Same as if we're finding a length, just still start with what you know and then substitute in. So in this case, we know that the angle that we don't know is called beta, and the opposite is 6.2, and the hypotenuse is 8.4. So therefore, beta must be sine to the minus 1 of 6.2 over 8.4, and we plug that into our calculator. So we've got shift sine 6.2 over 8.4, close our brackets, and it wants us in degrees to one decimal place. So 47.56 is going to round up, so that'll be 47.6 degrees. Okay, now our next example in degrees and minutes, correct to the nearest minute. So there's our reference angle here. We've got a side that's next door, so that must be the adjacent side, and we've got a side that's opposite that angle. Doesn't touch, the opposite side does not touch the angle. Okay, so in that case, the opposite over the adjacent, what trig ratio is that going to be? It's going to be tan or tangent. So tan theta equals the opposite over the adjacent. So then we just substitute in what we know. So tan, in this case, it's tan of alpha equals the opposite, which is 4.1 over 3.1, which is the adjacent. So therefore, alpha has to equal tan to the minus 1 of 4.1 over 3.1. And once again, we just put that into the calculator, making sure we press shift. Shift 10 gets us that minus 1. That means we're finding an angle 4.1 over 3.1. And we close our brackets and we get our answer. In this particular case, we want it in degrees and minutes. So we'll press the degrees, minutes, seconds button. 25 seconds is going to not round up. It's going to stay where it is. So we're just going to have 52 degrees, 54 minutes. Alrighty, moving right along. So we've got more of a couple of problem-solving style questions now. So we've got a 4.5 metre ladder, reaches up 2.3 metres up a wall. What the angle to the nearest minute is it resting against the wall? So once again, we label our sides. We assume that the wall is going to be built at right angles. So this is going to be our hypotenuse. This is going to be our adjacent side. Thinking of our trig ratios, which one uses adjacent and hypotenuse? So toa, cos is the adjacent of the hypotenuse, so cos theta equals adjacent over hypotenuse. Substitute in what you know and calculate what you don't know. So 2.3 is the adjacent and 4.5 is the hypotenuse. So theta equals cos to the minus 1, 2.3 over 4.5. So we put that into our calculator. Shift cos, because I'm finding an angle, 2.3 over 4.5. Close our brackets, equals, and we want this answer to the nearest minute, so we'll use degrees, minutes, seconds. So 59 degrees, 15 minutes and 43 seconds. 43 seconds is more than 30 seconds, so we round up, so it'll be 59 degrees, 16 minutes. Okay. The next example, we've got a 60 metre long bridge, has an opening in the middle and both sides open up to let boats pass underneath. The two parts of the bridge rise up to a height of 18 metres. Through what angle do they move? So we want to know what this angle here is. So we can just sort of forget about this side of the bridge and just think about this one side because they're going to move at the same rate. Now, if the whole bridge is 60 metres, then what we've got going on there, I had to think for a second there because I thought this isn't going to be 60 metres. If the whole bridge is 60 metres, then each of the two sides as they open up must be 30 metres. Because when these two come back down again, they've got to equal 60 metres. So if I think about my angle, I've got a hypotenuse over here. I've got an opposite over here. So that means I'm going to be using sine. Sine theta equals the opposite over the hypotenuse. Once again, I don't know the angle, so I'll leave that alone, but the opposite side is 18 metres and the hypotenuse is 30. So theta is going to equal sine to the minus 1 of 18 on 30. Once again, straight into the calculator with that one. Shift sine of 18 over 30. And we wanted to answer this question. It doesn't actually say, so I think in this particular case I'll just go to the nearest degree. So that's 36.8, it's going to round up to 37, so that's approximately 37 degrees. So in other words, the bridge bases open up to an angle of 37 degrees. And our final example here is find the value of theta using the formula m equals tan theta. So m being the gradient, remember rise over run, we did this when we did a bit of linear algebra. I think I've done that with you guys. If not, you would have done it in year 9. So in this particular case, this is our rise here. This is our run here. And remember that m equals the rise over the run. So let's think about this in terms of what's happened. As remember, we're always moving, when we're looking at gradient, we're always moving in this direction. So we started here and we started here at -3 and we moved this towards the origin. So if we were -√3 behind the origin, that means we've gone forward by √3, and if we're at the axis and by the time we got the origin we're 1 high, we've gone up by 1. So it's been a rise of 1 and a run of √3. So we therefore know that 1 over √3 must equal tan theta, because m equals tan theta. So that means that theta equals tan to the minus 1 of 1 over √3. And if we put that in our calculator, this is going to be one of those strange situations where we're going to end up with a nice round angle, and I will talk about why that is in a later part of this unit. But you wouldn't think a surd and trigonometry going together would give us a nice round number, but watch what happens here. 30 degrees. That's not 30 degrees to the nearest degree, it's exactly 30 degrees, and we'll talk about why that is a little bit later on in this unit. So that's the end of that lesson. Have a go at the questions and we'll move on to the next lesson next time. Thanks.